Okay, I don't normally show you how to do a lab, but this one some of you were struggling with, so I'm going to go ahead and post this. So let's start off with the mass of the iron sample. I'm going to invent a mass of my iron sample. I'm going to have my iron sample have a mass of, I'm adjusting my colors here, of, let's make it 5.0 grams. Let's just say that's what I have. Alright. Okay, now I'm just going to skip down past this part here. I want to look at number 6. This seemed to be a place that some of us were having difficulty, so let's just try this here. Alright, so let's try the first thing here. You know, you're not going to be very successful on this upcoming test until you come to terms with this. In an ionic compound, when you have a metal, the Roman numeral is telling you the charge on the metal ion. Because iron can have 3 different charges. It can be a +6, a +3, or a +2. These numbers do not tell me how many of these or how many of these. They are telling me the charge on this ion. So in other words, this is telling me that this iron here has a +6 charge. This one here has a +3 charge. And the last one has a +2 charge. That's what it's telling me. Now that means that if I make the chemical formula Fe and O always has a -2 charge. Fe in this case has a +6 charge. So we're going to swap numbers. I get a 2 to 6 ratio, but that reduces to a 1 to 3 ratio. So it should be FeO3. Now the next one, I have Fe and O. O once again has a -2 charge. Fe in this case has a +3 charge. So it will be Fe2O3. And finally for iron 2 oxide, Fe and O are both +2 and -2. So a 2 to 2 ratio is the same as a 1 to 1 ratio. That's all I need. I could, if I want, put a 2 here and a 2 here, but then that would reduce to a 1 to 1. Now I've got to find their formula weights. The way I do that is, for this one here, you know what, hang on a second. Let's just clean these up a little bit. Okay, so let's just start with the first one here. Alright, if I want to, here's my chemical formula, FeO, I want to find the formula weight. Sorry, I did it. I called it formula weight. We should be calling it formula mass, but here we go. In order to find that, what I'm going to do is, I see I have 1 Fe. I look on my periodic table, I see that has a mass of 56, plus I have 3 oxygens, so I'm going to say 3 times 16, which is the mass of 1 oxygen. And when I say 56 plus 3 times 16, I get a formula weight of 104 grams. If I have 1 mole of FeO3, its mass is 104 grams. Let's look at iron 2 oxide. In this case, what I would have to do is I would say, well, here I've got 2 times 56, because I have 2 Fe's, plus I have 3 times 16, because I have 3 oxygens. And that's going to give me a formula weight of 160 grams. And lastly, we'll do FeO. In that case, I have 56 plus 16. I'll use my calculator. I should be able to do that in my head, but I get 72 grams. So listen, I don't want to do all your work for you, so I'm just going to do number 8. Alright, let's just try this here. Alright, so we're going to say how much of this compound here, iron 3 oxide, could we have made with our starting amount. Now if you'll recall, for the purposes of this web help, I'm saying I had a starting mass of 5 grams of Fe, and I'm going to write down the Fe. I'm not going to be lazy. I start off with that. I don't want grams of Fe, so I'm going to put grams of Fe in the basement. And I can turn that into 1 mole of Fe. And when I look at the periodic table, since I've got grams, I have to look at the periodic table and I'll see is 56. It takes 56 grams of Fe to make 1 mole of Fe. But I don't want moles of Fe, so I'm going to put mole of Fe in the basement. I'm not going to put a number yet. I'm just going to say mole Fe. And at this point, what I'm going to do is I'm going to turn moles of iron into moles of iron 2 oxide. Now, if you'll recall, the formula, the chemical formula for iron 2 oxide is Fe2O3. So what I'm going to do now is I'm going to put moles of the compound up above. We do this quite a bit in stoichiometry, which is what we're doing. We are going to say how many moles of Fe are there in 1 mole of this? And the answer is right here. There are 2 of them. There are 2 moles of Fe in 1 mole of Fe2O3. So I'm going to say you have 2 moles of Fe in every 1 mole of Fe2O3. Now, what I have up above is moles of Fe2O3, which I don't want, so I'm going to multiply. And I'm going to put mole Fe2O3 down below. And I've been asked to find out how much iron oxide, so I'll assume that's in grams. Grams of Fe2O3. And if you recall from the other side, what we found is 1 mole of this compound had a formula mass, a formula weight of 160 grams. So once I get what I want up above, grams, I'm going to put an equal sign. And let's just see how much I get. In this case, what I'll do is I'll say 5 times 1 divided by 56 times 1 divided by 2 times 160 divided by 1 equals. And when I put all that through my calculator, what I get is 7.1428 blah blah blah, but I had 5.0 to start with. That's 2 significant figures, so I'll say 7.1 grams. Now you're going to do this for all of these. You're going to do this for number 7, and let's just say you come up with 6.4 grams. And let's say you do it here and you come up with 5.8 grams. And what you do then is to decide which one you've made. So for number 10, what I would do for number 10 is, it says which of the 3 iron compounds is closer to measured value. So I check these here, 5.8, 7.1, 6.4, and on the other side, let's take a look at the other side. So just let's say on the first side where it said what was the mass of the iron compound that formed after you did the blowing your air on it while it heated up. Let's just say what you had was 6.2 grams is what you measured. So what you would do is you would compare this to the 3 values on the back. Now 6.2 comes closest to 6.4, so if this was the case, I would say that what I produced was probably iron 6 oxide. Now keep in mind, that doesn't mean that's the answer. I'm not doing your homework for, I'm just showing you how to do it. But whichever of these values here came closest to the one on the front, that is what you would put here for number 10, for which of these you made. Then, and let's just say what I had was 6.2, and that came closest to 6.4. Let me show you how to do this last one then. Okay, so let's just say again that on the front side I saw I had 6.2 grams. So I say, well, that means I made FeO3 because that came closest to the 6.4 grams I found on the back when I calculated. The one on the back is my calculation, or my predicted. So in order to do this last part, and this is a fairly standard thing to do on chemistry labs, is that you try to predict how far off you are. We have a thing we call percent error. You take the absolute value of the difference between what you would have predicted using your chemical equations and what you actually measured. You divide it by your prediction and you multiply it by 100% to get a percent value. So here's what it looks like. So our predicted mass in this case would have been this value here, 6.4. You might have chosen one of the other ones depending on the data you got, but for me, on this fictitious lab, this is what I got. So, 6.4 is my predicted mass. I'm going to take the absolute value, minus, what did I actually measure? Well, on the front side, I actually found that I ended up with a mass of 6.2 grams, so that's my measured mass, 6.2. Take the absolute value of that and divide it by the predicted, and the predicted in this case would have been the 6.4 that I found on the back, and I'm going to multiply that by 100%. just so I can express it in those terms. So let me just go ahead and take out my calculator real quick. So I'm going to say 6.4 minus 6.2. I'm going to divide that by 6.4. I'm going to multiply by 100%. And I'd have an error in this case of 3.1%, which, by the way, would be spectacular. No one expects you to get that close. I would hope that you got within 10 points, and if you didn't, you should be asking yourself, what is it that might have caused you not to get this? I didn't have room on this paper, but that's one of the things that you need to start thinking about. What could have caused you not to get a percent error of 0? My guess would be it'd have something to do with the fact that not all of the iron reacted. If all the iron didn't react, I wouldn't have gotten as much oxygen, and therefore the mass would have been lower. Or some of it might have fallen off. So, as you blew it, you saw little glowing pieces fly away. That again would have introduced some error. So when you're answering a question about error, that's what you want to think about, is what are some sources of where you might have ended up getting a value other than what you actually measured. Hope this helped.